Very good morning to one and all. Today we are going to understand one of the important topic from the theory of computation, which is from the unit 1, that is finite automata and regular expression. So before moving towards the finite automata and regular expression, let's clearly understand what is theory of computation. What computation word denotes. Computation means nothing but any task which is performed by the computer or the calculator. So uh, now what is theory of computation? Let's see. So theory of computation means, let's suppose it is, we can say it is a branch that deals with how efficiently the problems can be solved using the model of computation, can be solved by model of computation using some algorithms. So the desired regular expression, so here unit 1, it is given as finite automata and regular expression. So the desired regular expression here is the union of the all the expressions derived from the reduced automata. Expressions here are derived from the reduced automata. Automata is nothing but an abstract machine for each accepting state. Whenever the states accepts it, we get an reduced automata from the regular expression. So every language defined by the regular expression is also defined by the finite automata. Now this finite automata is nothing but an abstract, we can call it as an abstract machine also. Now let's see the content to be covered in the unit 1. So first is the definition of deterministic automata. Now as the finite automata is of two types, it is a deterministic and non-deterministic finite automata. So firstly we are going to deal with deterministic definition of deterministic finite automata. Based on that, some problems we are going to study, and after that non-deterministic finite automata. Then we are going to see the two types of machines, that are Murray and Mealy machines. After that regular expression, then a recursive definition, NFA with epsilon moves, that is not E moves, it's actually epsilon moves. Interconversion between NFA and DFA, then regular expression and finite automata. Then finally a pumping lemma test is there. Pumping lemma, it is also a negativity test to check whether the regular expression, whichever is the regular expression, that is accepted by that automata. Now so automata theory is a theoretical branch of computer science and mathematics. As you all know that it is theory of computation is also called as the automata theory. So it is a theoretical branch of computer science and mathematics which deals mainly with the logic of computations with respect to simple machines referred as automata. Automata enables the scientist to understand how machines compute the functions and solve the problem. Main motivation behind being automata theory was to develop methods to describe and analyze the dynamic behavior of the discrete systems. Automata is originated from the word automaton, which is closely related to automation. Now if you are using any textbook for the reference, you can use John Hopkett and Raju Ullman textbook to refer the theory of computation, introduction to theory of computation. That textbook is there, which I prefer. So automata theory is the study of what that is abstract computing devices or the machine. Before there were computers in 1930s, what Turing did, Alan Turing is one of the scientists that you will see. Uh, Before in 1930s computer, you can see this. It has a capability, the capabilities of today's computer, at least as far as it what could they could compute. In so earlier, what was happening, the before the 1930s, the Turing, what he just believed that what a computing machine could do and what it could not do. Then he accordingly designed such simpler kind of machine with the help of N. Chomsky, simpler kind of machine which he called as just a finite automata. A simple kind of machine he designed in 1940s and 1950s, which was called as a finite automata. After that, Alan Turing, who is the father of modern computing, he is a as you can see that he is a brilliant mathematician and the logician. He developed the idea of the modern computer and artificial intelligence too. In in the 1930s time only he built that. During the Second World War, he worked for the government breaking the enemy code, and the churches said he shortened the war by 2 years, and it's really a great deal. So after that, in 1930, as we know that Turing studied what computing machine could do and could not do, and in 1940 he designed a finite automata. And then 1950, and Chomsky studied this formal grammars. Then, then in 1969, the Cook, scientist named as a Cook, explains the study of what a computing machine could do and what he could not do, what not to be computed. Cook was able to separate those problems that can be solved efficiently by the computer from those problems that in the principle be solved, but in practice take so much time that computers are useless for all but very small instance of the problem. Latter class of problem was the intractable or the NP-hard problem, which was uh, it is highly unlikely that even the exponential improvement in the computing speed that computer hardware has been following will significantly impact the ability to solve the large instance of intractable problem. Later on, some intractable and hard NP-hard problems were also solved by the machines. So why to study an automata theory? Now all these theoretical developments which was done year by year, this has been directly impacted, and the computer scientists today develop various inventions. Some of these concepts like finite automata and certain kind of formal grammars are used in the design and the construction. With the help of grammars and the language that was and the machines that were designed, the some design and the construction of important kinds of softwares were designed. Other concepts like Turing machine helps us to understand what we can expect from the software. Turing machine told us that what we can expect from the software. So introductory chapter deals with, here we begin with a very high level view of automata theory and what its uses are. Then we are going to have a survey on the proof of techniques and discovering the proof. We cover the deductive proof. We will cover here the deductive proof, reformulating statements, contradiction proofs by induction, and the other important concept. Final section introduces the concept that pervades automata theory, alphabet, strings, and language. Why one should study an automata theory? So by giving only one reason, we can't prove that why should one study an automata theory. So there are several reasons of automata, and complexity is an important part of the computer science. So introduction to finite automata. uh, Useful model for any important kind of hardware and software. So let's list some of the important kinds. So first is software for designing and checking the behavior of digital circuit. From this we can design such a type of software which will design and check the behavior of what digital circuit zeros and ones. Lexical analyzers of a typical compiler. In compiler construction also there is a application to this that breaks the input text into a logical unit. That is the first phase of the compiler, such as identifier into logical units such as identifiers, keywords, and punctuations. Then software for scanner. As a scanner also it works. That is like a third phase, second phase of the compiler. Large bodies of text such as collection of web pages to find occurrence of words, phrases, or the other patterns. Um, how many times that word or phrase has occurred, that pattern has occurred, that occurrence can be found by using a compiler, by using a theory of computation model. Software for verifying the system of all the types that have a finite number of distinct states, such as communication protocols or the protocols for secure exchange of information. So these protocols can also be found. Then advantage of having the finite number of state. So uh, finite number of state sets means the fixed set of resources. For example, we could implement it in a hardware of a circuit or a simple form of program that can make a decisions. So as finite number of states are means the limited amount of the data is there, and using the position in the code itself to make the decision. So fixed position will be there and fixed set of resources will be there. That's why it is called as a finite number of states. Now let's see example. So you all understood that automata, this is originated from the word automaton, which is closely related to automation. So automata, you know that it is the theoretical branch of computer science and the mathematics. It deals with what logic of computation. So here with respect to what simple machines, which is referred to as automata. So here simple automata is being designed on the on state or the off state. Perhaps a simple non-trivial finite automata, and this machine simple, that diagram is nothing but the finite automata based on or off switch. Device remembers whether it is on state or the off state, and it allows the user to press a button whose effect is depending upon the state of the switch. So if the switch is in the on switch is in the off state, then after pressing the button it changes to the on state by applying the push operation. Here first arrow starting state, whichever is the starting state is represented by the start symbol and followed by the arrow, wherever, and the circles represents the state and the arrows represents the transitions here. So here off is the starting state and on is the accepting state or the final state. So here whenever the switch is in the off state, then pressing the button it will changes to the on state, and whenever it is in the on state, then pressing the button it doesn't. So states represent by the circle on and off. Two states are there, and the arcs between the state represents what, that is on the arcs we had written push, which represent the external influences on the system, and the others are the start state and the accepting state. This is one of the basic example, and the other example the for of the job of this automation is to. Now second automata is there. So we automaton, this automaton is there. So job of this automaton is to recognize the keyword, then it thus needs five states, each of which represents a different position in the word then that has been reached so far. This position corresponds to the prefixes of the word ranging from the empty string, that is nothing of the word has been seen so far, to the complete word. So after first of all be giving T, it moves to the other state small t. Then after H it moves towards the TH. Then after giving the next letter E, it moves to the another state TH. So after accepting the final letter, that is N, it is moving towards the final state, that is the then accepting state. So what is basically a theory of computation? As you all know that now, just before I told you that computation means any task which is performed by the computer or the calculator. TOC is the branch that deals with how efficiently a problems can be solved using model of computation using an algorithm. So basically it deals with the three things. First is the automata theory and the language. In automata theory and the language, we will understand two types of automata, that is finite automata and push down automata. Computability theory, it basically deals with the Turing machines, how the machines are computable, that compatibility will be checked. Then computational complexity, it is related to the research. Basically students not deal with the technical students, basically it is for the technical, not for the technical students. Okay, so all the sets concepts in the automata theory and the language, first of all basic prerequisite will be the set theory. In that we should know the power notations and all the basics of the discrete mathematics. Then the definition of TOC, that basically deals with the strings, alphabets, language, sentences, grammars, application, automata. So automata are of different types like finite automata, push down automata, and then Turing machines. Then we also need to understand the derivation, pass tree, and all the basic concepts. Thank you very much. These are all the basics of TOC that we will see in the next lecture. Thank you very much.